Hi there. Hello and welcome to Fun Tips, where we make electrical engineering simple, visual, and fun for everyone. If you are just starting out or just curious about how electricity works, you are in the right place. You use electricity every day. But have you ever stopped to think? How does the power travel all the way from massive power station to your teeny phone charger? There is one powerful device making it all possible, silently working behind the scene. It is called transformer. In this video, I will answer the 7 most common transformer questions. Explain it in clear, simple words with a real-life example. Let us make this easy and actually fun to understand. Ready? Let's go. Question number 1. What is a transformer and how does it work? A transformer is a device that changes voltage either up or down. Imagine this. 2 coils of wire wrapped around a metal ring. Electricity goes into the first coil. It creates a magnetic field. That field passes through the metal and creates electricity in the second coil, but at different voltage. Power companies use this to their advantage. High voltage is great for sending electricity long distance, but that is dangerous for home use. So before power reaches you, another transformer reduces the voltage, make it safe. So transformer does not create electricity. They just change a voltage, so it is useful and safe. Question number 2. What is the difference between step up and step down transformer? Easy. It is all about how many turns the coil has. If the output coil has more turns than the input coil, the voltage goes up. That is a step up transformer. If the input coil has more turns, the voltage goes down. That is a step down transformer. We use step up transformer near a power plant to boost voltage for long distance travel. And we use step down transformers in near home and buildings to lower voltage, so it is safe. Question number 3. Why are transformers rated in kVA, not kW? Here is the key. Transformers does not use power. They use create. So instead of measuring how much is used, kW, or we measure how much they carry, kVA. Think of it like a truck. kVA is the total weight the truck can carry. kW is how much of that weight is actually useful. No matter how full the boxes are, the truck still needs to carry the total weight. That is why transformers are rated in kVA. Why can't transformers work with DC? Transformers only work with AC, alternating current. Why? Because they need a changing magnetic field. AC changes direction, creating a field that moves and energizes the second coil. But DC follow in only one direction. That magnetic field does not change, so nothing is happening. It is like pushing a swing, pushing it one and stop. DC, that's the swing stop. Keeping pushing back and forth. AC, the swing keeping moving. That is why transformers need AC to do their magic. Question number 5. What is voltage regulation and why does it matter? Voltage regulation tells us, does the voltage stay stable when you plug things in? If the voltage drops too much when a load is added, that is bad regulation. If it stays closer to the target value, that is good regulation. Think about a hospital machines like ventilators need steady voltage. A small drop could cause a stress problem. That is why we want to low regulation so voltage does not fail when it matters most. Question number 6. What are transformers' laws? Even though transformers are known for being highly efficient, they are not perfect. Just like any device that handles energy, transformers experiences some losses, mostly as heat. There are 2 main types of losses. copper loss, also called winding loss. This happens in the wire or coil inside a transformer. As electric current flow through them, they heat up. That is because of the resistance. You may remember that formula: power loss is equal to current square times resistor. That higher the current, the more heat is produced. It is just like when your phone charger or laptop adapter feels warm after a while. That heat is the result of copper loss. Number 2, core loss, also called iron loss. This happens in the iron core that links the two coils. There are two causes of core loss. The hysteresis loss, because the magnetic field keeps changing direction in AC, eddy current loss, swirling current inside the metal that turns into unwanted heat. To reduce this, engineers laminated the core, cutting it into thin sheet, just like slicing bread. This stops the eddy current from flowing in a large loops. How does we reduce these losses? We use high quality copper with low resistance, thin laminated cores, special alloy that reduce magnetic loss, and even cooling system like oil or in a large transformer. All this improvement help make transformer incredibly efficient, many above 98%. That means for every 100 unit of power going in, 98 units come out useful, and only 2 are lost as heat. Question number 7. Why are transformers so efficient? Transformers are super efficient because they have no moving parts, no friction, no spinning, just smoothing magnetic energy transfer. With a good materials and design, they waste every little energy, some a little as 1% or 2%. Power companies love this. A city running 10,000 transformers means as 1% or 2% losses difference can save millions of dollars. Bonus: can a transformer increase both voltage and current? Just short answer, no. You cannot increase both at the same time because energy must be conserved. If you step up the current, voltage must be dropped. Transformers balance voltage and current, but they never multiply energy. So now you know. Transformers make modern life possible. From massive power line to your phone charger, they are everywhere. Simple, silent, and powerful. Which question helped you the most? Or what topic should I simplify next? Drop it in the comments. Don't forget to like this video, subscribe, and ring the bell. Thanks for watching. This is Phantom Tedious, engineering that sparks curiosity.